Finally, the problem has been solved thanks to the combination of the moon and the high tides. But what were the reasons for this delay? Why couldn't it just be pulled or dug out straight away? This is what I will now explain. Let's get started. In order to understand the gravity of the problem, let's understand the location of the giant container ship. The first thing we need to understand, in the south of the Suez Canal, there is a single canal, and in the north, there are dual canals, or two canals, and the MV Ever Given is stuck in the south and not in the north. If it were to be stuck in the north, then this would have never occurred, due to there being two canals. The MV Ever Given is 400 meters long and goes as deep as 15 meters, or 45 feet. Also, the total weight of the vessel is 200,000 tons. That is the same as 200,000 cars. Due to the vessel no longer floating anymore and it landing on the beach, it can't be moved around. In the picture, we can see that the nose of the vessel has hit land, but what is difficult to see is that the nose is just the beginning of the problem. Since the vessel may go as deep as 15 meters, it is very likely that the vessel at this point is about 15 meters embedded into the seabed. Since the vessel is now on the sand, it has become a frictional problem. To move the vessel, this is the same as when we are dragging a box on the table. Part of the vessel is now resting on the sand. If we assume that it's around 1/3 of the vessel weight that is resting on the sand, then the frictional force required to move the vessel is around 50% of the weight resting on sand. That is 50% of 1/3 of 200,000 tons, which means that is 33,000 tons. So 33,000 tons will be required to pull to move the vessel away from the sand. The vessel Far Samson has the highest pull capacity in the world. It has a capacity to pull 420 tons. That means that we would need at least 80 Far Samsons to pull the MV Evergreen free. And there's just not enough space in the channel to have 80 vessels pulling all at the same time. The Far Samson is the only one of its type in the world. A second option is to dig underneath the vessel. So if the vessel is 15 meters below the sea level, then from land, an excavator must likely need to stand 30 meters from the vessel, reaching 15 meters deep. The reason that the reach is likely 30 meters is that it's not possible to excavate vertical in sand underwater. Sand will simply flow out and can't remain stable. I don't think there is an excavator that will have this type of reach. The reach is simply too long. The next option is to use an offshore dredge, which will suck or excavate soil underneath the vessel. These types of dredging vessels are mostly designed to escalate underneath the vessel and not horizontally in front of the vessel. Therefore, these types of vessels are not built to face this type of challenge. They are offshore excavators. But again, they are not designed to dig so long in front, but maybe this could be a possible solution. Another solution could have been unloading the vessel, which would mean taking off all the containers. But the challenge is that the vessel is designed to be offloaded whilst in port, so cranes may struggle to lift all these containers off. Either way, lifting containers off will take a very, very long time. Thank you for watching this video. I hope you enjoyed it. But if you were to ask me how I would have solved this problem, we can just simply ask Thanos to click his fingers to make this problem disappear. See you later. Bye.